I'm Noelle Bakhtian, Executive Director of the Berkeley Lab Energy Storage Center. Today, in partnership with my colleague Johanna Nelson-Wecker, I'm excited to announce the launch of a new virtual field trip seminar series called Exploring the World Unplugged, The Secret Life of Energy Storage. The Department of Energy's Berkeley Lab is partnering with SLAC National Accelerator Lab to launch this virtual field trip seminar series, which will highlight current and future uses of energy storage, one of the linchpins for catalyzing decarbonization, with major implications to electrifying mobility, accelerating renewable energy deployment on the grid, and enabling energy resilience. Each tour will showcase a real-world application of energy storage, provide a discussion on related science and technology research, and include an opportunity for you to ask questions. Together, we're going to learn more about how energy storage plays a pivotal role across sectors. To learn more, get notifications, and reserve your seat, visit us at our website, secretlifeofenergystorage.lbl.gov. Now let's kick off our first field trip, where we're going to get a chance to check out energy storage in space. We'll start with a 5-minute video from NASA that introduces our distinguished tour guide, astronaut Kayla Barron, and then we're going to blast off on our field trip to the International Space Station, where we'll have a discussion with her about the energy storage system used on the space station and their continued contribution to energy storage research and development.
All right, NASA family and friends, our first astronaut, Kayla Barron.
I think the thing that's most important to me is just the inspiration of exploration. I think we all have this innate sense to explore, whether you're the one who actually gets to step on the moon or not. I think it changes all of us to know that we can actually do things that would be unimaginable to the generations that came before us. 9/11 happened 8 days before my 14th birthday, so I was in 8th grade. And I was really inspired by how our country responded to that really tragic event. It really made me realize that I wanted to serve and commit myself to something that was bigger than just me. And there's a huge diversity of opportunities in the Navy, whether it's flying a plane, driving a surface ship, driving a submarine, being a doctor. And I spent a week with the submarine warfare community, including a day underway. And I was so impressed by the sailors on that submarine. They just seemed like the kind of people who would teach me how to be a good leader. For me, the dream of becoming an astronaut cemented itself pretty late in my life. I went back to the Naval Academy to work for Admiral Ted Carter. And because I was working with him, I got to go to all of these really cool events and meet a lot of people who I had no business talking to, really. I met one of his classmates, former astronaut Kay Hire, and she was telling me about one of her shuttle missions where they were building the early space station. And I said, that sounds a lot like a submarine in space. She looked at me and she was like, it totally is. That's exactly what it's like. And that was sort of the lightning strike moment. As a kid, I knew about astronauts. I watched shuttle launches on TV. I knew we were in space, but never seemed like something that I could do. But I had really good mentorship at that time. I shared that dream with my boss, Admiral Carter. He turned to me and he said, Kayla, do you know how you become an astronaut? You apply. And for me, that was the perfect mentorship I needed in that moment. I'm somebody who thinks really hard about everything I do, all the details. And he said, it's actually pretty simple. You just got to put yourself out there and you never know what's going to happen. So I did apply and it ended up working out. Here I am.
I think you're one of my favorite people.
And there's a wide shot of the room with the 4 Crew 3 astronauts. We have Commander Raja Chari, pilot Thomas Marshburn, mission specialist Kayla Barron, Matthias Maurer. And here they are, the 4 Crew 3 astronauts as they walk down the hallway on their way out of astronaut crew quarters. And here they are, indeed, the Crew 3 astronauts taking their first steps outside before their journey to space.
All stations. Crew have locked out and ready for revolutions.
There they go. there's a view inside the crew access arm as they make their way looking out the windows. We'll watch Tom ingress to the Dragon capsule carefully. Watch your head.
Yep, watch your head, watch the seals.
4 crew members of Crew 3 now inside Dragon.
And you can see the suit techs are there helping them get strapped in. Initial comm checks are now complete. Next up will be seat rotation.
As you can see, the hatch being closed right there. And there is the retraction.
3, 2, 1, 0. Ignition. And liftoff.
Laboratory in orbit, the International Space Station. Vehicle is pitching downrange. And that's the call we want to hear. Good performance on that first stage so far.
T plus 30 seconds, Captain 9, powered by 9 Merlin 1Ds. Pushing Dragon into low Earth orbit on the way to the International Space Station.
Power and telemetry nominal.
Station, this is Houston. Are you ready for the event?
Houston, this is Station. I'm ready.
Kayla, greetings from Earth. We are so honored that you've taken this time to talk to us. I'm Noelle Bakhtian from the Department of Energy's Lawrence Berkeley National Lab, where I lead the Energy Storage Center. And I'm joined by my colleague, Faith Dukes, Director of K-12 Programs, who works every day at inspiring young people to have careers in STEM.
It's such a pleasure to be with you guys today. Thanks for having me.
We are over the moon excited to be sharing this conversation with folks from across the country attending our National Energy Storage Summit. We almost feel like we know you because we just watched part of your bio and your launch. I'm going to turn it over to Faith for the first question.
Thanks, Noelle. And Kayla, it's so great to be speaking with you. Does your out of this world view of the Earth make you think differently about the condition of our planet?
Yeah, it's really hard to put into words the experience of seeing the Earth from this incredible vantage point in low Earth orbit. I think for me, looking out the window really highlighted a couple of things. First of all, it's amazing. You can actually see the edge of the atmosphere from space. And seeing that with your naked eye, it just, I think, drives home how fragile our planet is and how miraculous it is that it even exists and could support not only human life, but all of the amazing plants and animals all over our planet. And so I think for me, it drives home the importance of protecting that for future generations so that they can enjoy our gorgeous planet the way we have. And then the other thing that really comes to mind is you get used to thinking about the world as this place that's divided up into countries, states, all these borders, different colors on the maps you saw in school growing up. But looking at it from this vantage point, you just see how we're just one giant interconnected organism on our planet, and how those borders, while they're important in our everyday lives for a lot of the functions of our government and stuff like that, we're really one human race that is sharing this home, and we really need to work together in order to protect it.
That is so profound. And the first thing I thought of when you mentioned fragility of our planet and working together to protect it was climate change. Climate change drives a lot of us, and it's the main driver for this summit. We see energy storage as a linchpin for clean energy solutions. Can you talk us through how the International Space Station is powered and why you need energy storage?
Yes, absolutely. Energy storage is vital to what we do every day on the space station, and it is really important as we think about future exploration on the moon and Mars. We're actually powered by solar arrays. We have 8 power channels, 8 really large solar arrays that send power onto the space station when we're on the sunlit portion of the Earth, but we're also charging batteries that entire time as well, so that we're in the shadow portion of the Earth, we can draw power from those batteries. So those heritage arrays, those 8 big solar arrays, are what we've been using to power the space station for the last 21 years. And we're in the process of upgrading that solar array system by adding some augmenting arrays. We call them IROSAs because we love our acronyms. You might too at the National Lab, but it stands for ISS Rollout Solar Arrays. And basically they're these solar arrays that we're installing at the base of our existing solar arrays to provide additional power for new requirements and to account for the degradation of those the heritage arrays over time.
It's almost like you have a microgrid up in space. That's a great parallel to our power grids on Earth. As we're working on transition to clean power by 2035, that requires adding in a lot of clean energy sources like solar and wind power, which are intermittent. But energy storage is a major part of that solution space. We'd love to learn more about the energy storage system you've got on the International Space Station, though. What kind of system is it?
So originally we had 48 really big nickel hydrogen batteries that are stored outside on the truss of the space station. And from about 2016 to 2021, I think, we worked on upgrading all of those. So we actually removed the heritage batteries and replaced those 48 batteries with 24 lithium ion batteries. They're huge. They weigh about 400 pounds on Earth. So they're pretty big beasts to manage on a spacewalk. But those were all upgraded. And so those allow us to store power that we're producing when we're in the sunlit portion of our orbit. So usually we use about 40% of the solar array capacity while we're in the sunlit portion, and the other 60% of that energy is getting stored in those lithium ion batteries for us to draw from when we're in eclipse.
Wow, it's just so fascinating. When I was learning about the history of storage on the space station, the battery upgrade process took 8 years of R&D, 4 cargo flights, 13 astronauts, and 14 spacewalks. And it just got completed last year. It's so exciting. What really stands out to me is the people and the expertise and the capabilities that need to come together to enable something like that. Energy storage definitely takes a multidisciplinary team to bring clean energy to multiple sectors. In fact, right now, Berkeley Lab is working with NASA to find solutions to decarbonize aviation.
Yeah, and I couldn't agree more about the importance of that interdisciplinary team and this commitment to, in that case, powering the space station, but also driving clean energy solutions for our planet. NASA, we're known for space exploration, but a lot of the science and research and development we do has applications back on Earth, just like you mentioned, for things like making our commercial air travel greener.
I'm going to switch up things, and I'd like to talk about what it's like to do science in space. Just last year, the ISS hosted an experiment on the impact of microgravity on plant microbe interactions. And our researchers here at Berkeley Lab did the post-flight analysis on this astrobotany project. Could you tell us more about what advantages space offers to the experimental environment and what the opportunities might be for energy storage researchers that have an idea for an ISS experiment?
Yeah, you guys are at a national lab, and I'm at one too, up here on the International Space Station. And it's a really unique laboratory environment because we're working in apparent microgravity, and we also have access to some unique environments if we do experiments outside the space station in the harsh environment of space. And so it presents a lot of really interesting research opportunities in almost any field. We're constantly doing medical research. We're doing research on life support systems, on energy systems, like you mentioned. And we're trying to both further advance science for benefits on Earth, but also figure out all of the things that we need in order to succeed in future exploration missions on the moon as part of the Artemis program, and then when we travel even further onto Mars. So there's a ton of opportunities specifically for energy storage, like you mentioned. We really need more efficient, more compact, lighter energy storage systems. We need to increase the density of those systems so that we can store more energy in a smaller space, because it's really expensive to launch things, but we also need room on these vehicles for all of the other equipment we're going to need on these missions that are super far away from home. And so figuring out new ways to store energy more efficiently and keep it has to be really safe. It's part of our spacecraft. So figuring out how to deal with things like thermal runaway with lithium-ion batteries are all things that we're working on at NASA and that we can use a ton of help with to develop new solutions.
Okay. Talking about your R&D capabilities, there are numerous reasons to want to manufacture new parts in space, including ready access to replacement parts for repairs and the high cost of sending anything into orbit. What experiments are ongoing or planned to explore manufacturing new parts through 3D printing at the ISS?
Yeah, this is a really exciting capability. We've been 3D printing aboard the space station since 2014. And it is really important. That capability could really reduce the amount of things that we have to bring with us. And there are always going to be problems we could never anticipate. We're going to run into things that we didn't think about before we launched. And so the ability to create new tools, create parts, fix things that are broken is really important. We've done some really cool things with our 3D printing up here already, like making tools, adapters for our ECLIS system to hold an oxygen probe. And there's other interesting applications in a different kind of 3D printing for like bio applications. We're also looking at 3D printing organs in space because the microgravity environment is a lot closer to mimicking what our organs are actually like inside our body floating around. And so we'll be able to actually 3D print organs that are then transplanted into patients on Earth.
Something Faith and I were so curious about. What inspired you to be an astronaut? What influenced your decision to take a STEM path?
Yeah, I was really lucky to grow up in communities that had strong science and engineering industries. My dad works in the nuclear power industry, and my mom is a math whiz. And so growing up at home, I was always really encouraged to maintain my curiosity about the world around me, and that meant for me an interest in science and math and ultimately engineering. So I was really lucky that I was surrounded by people who didn't think my questions were annoying. My parents always entertained my questions about the world around me, which was really encouraging. And I had some fantastic teachers who really kept me going. As we all know who have studied STEM fields can be pretty challenging, and they're tough concepts. And as a student with a lot of heavy course load, it can be tough to get through those classes. But I had some fantastic teachers who really encouraged me to stick with it and helped me understand that that passion for the world around me could be best applied by studying engineering. And I'm really glad I followed that trajectory. For me, I've always been inspired to work on mission-driven teams with awesome human beings. And so that drew me to join the military and become a submariner, and ultimately inspired me to apply to be a part of the NASA team because I was so inspired by the things that we were doing. I just wanted to be a part of that team. And I'm really lucky that for me includes the opportunity and honor of working aboard the space station for 6 months.
Let's loop back to energy storage for a bit. Why is energy storage so critical to space exploration, and what kind of energy storage innovations are needed to help humanity further explore space?
Yeah, NASA's excited about our next missions, and that's the Artemis program. We're returning to the moon, and we're returning to the moon in a different way than we did in Apollo. This time we're going to stay. We want permanent habitats on the surface of the moon, and that means that we need to be able to not only produce but store energy. We're talking about going to the lunar South Pole, which has some really extreme lighting conditions. Some areas are in permanent sun, some in permanent shadow, depending on where you are. And so understanding how that we can use in situ resources, how we can safely produce and store power is going to be critical to achieving all of our science and engineering goals on the moon. And then when we go to Mars, we're going to need really efficient, really reliable equipment that can be serviced by astronauts who may or may not be experts in those systems. And so furthering all of that equipment, making it more reliable but also simpler to use is going to be really important for those future missions.
That sounds like an incredible challenge, but it's absolutely what we need to strive for. I'm also thinking about the extreme environments, temperature, radiation, long duration, for everything from Moon to Mars to deep space probes, just all very exciting scope for researchers and the people at the very cutting edge of deployment like you. This is just flying by. Here's the last question. There are a lot of people out there, including me, who are very inspired by space and exploration, in part because it gives us a new way to think about our role in the universe. Kayla, based on your unique perspective, what do you see as our future, humans' future in space?
It is a really exciting time to be working for NASA. There's some amazing things happening, new commercial companies that are doing operations in low Earth orbit, both in partnership with NASA as part of the Commercial Crew Program, but also on their own. So I think low Earth orbit and space is going to become more and more accessible to human beings to travel to it, but also to researchers to continue to do amazing things in this unique environment. And for NASA, we've really set our sights on doing things we've never done before, on exploring again and on pushing the boundaries of what people think is possible. And so we are headed back to the moon. We're going to put human boots on the moon, hopefully in the next few years even, and develop those permanent habitats we were talking about earlier. And all of that is as a proving ground to help us develop the operational concepts, the technologies we're going to need to take a huge leap and head to Mars, which is kind of hard for me to wrap my head around, but that's something we're going to be doing in our lifetimes and hopefully during my career as an astronaut. So it's a really, really exciting time to be engaged with space, and I just can't wait to see what the next couple of years bring.
So do you think that we or generations after us will ever be able to say, beam me up, Scotty?
Here's hoping. We're actually testing some HoloLens, like using a HoloLens to bring holographs up to the space station, bring other people up here with us. So maybe we'll start there, and eventually we might actually get teleportation. Who knows? We'll cross our fingers.
I love that. That's incredibly motivating. With that, I'll just close by saying we're just so grateful for everything you're doing in the pursuit of innovation and inspiration. Thank you so much, Kayla. It was really wonderful to talk to you.
And it was my pleasure. It's so awesome to talk to you, and thanks for all of the awesome work that you're doing in support of our climate and energy storage and hopefully also space exploration.
Station, this is Houston ACR. That concludes the event. Thank you.
Thank you to all the participants from Lawrence Berkeley National Laboratory. Station, we are now resuming operational audio.